In this video, we'll look at radians, and I'll also talk about supplementary and complementary angles. Okay, we've so far been using degrees. So if you go all the way around, that's 360 degrees. Now, if I have any circle with a certain radius, and if I take that same length and I just kind of press it over so that it stretches along that curve, and that's called an arc length. Okay, so I'm just going to stretch that over. Okay, the length of that curve right in here is the same length as our radius. Now, if I draw another line that connects the center of my circle with the end of that arc length, it's going from the center out to the edge, so that also actually is an R, a radius. The measurement that we create in here is 1 radian. This was a radius. Okay, so that idea of a radian is that when an arc has the same length, as the circle's radius, then the angle measure is 1 radian. Okay, so how many radians does it take to get around the circle? Well, you can actually do this, with something round, like a coffee filter or something like that. But it turns out that there's one, there's another one. You can fit a third in here. And then a little tiny piece of one, this little section in here, actually ends up being 0.14. So it turns out that there is 3.14 lengths that have the same length as your radius to get around a circle, and that is pi. Okay, so in terms of degrees, halfway around is 180, and in terms of radians, that is pi radians. Okay, and then to get all the way around, that's 2 pi, and we would just call that rad for radians. So since 180 is 1 pi radians, you could divide both sides by pi, and you get our conversion here. Okay, so if I want to try and convert, if I'm going from to pi, and I want to just verify that I already know it's 360, but let me just show you how to convert from radians to degrees. Okay, this is in radians. If no degrees are given, then you can assume that we're in radians. Okay, so no degrees were given, we assume we're in radians, and then we want to get rid of radians. 180 degrees is the same thing as pi radian. So you just multiply by the unit fraction there. My radians cancel out, my pi's cancel out. So this is 2 times 180 degrees, which is 360 degrees. So every time you're trying to convert, you're just going to multiply by a unit fraction. So for here, I would take 57.2958 degrees. Okay, and so if I'm converting, I'm in degrees. I want to cancel out my degrees, and so then I just write my unit fraction. 180 degrees is the same as pi radians. Those are radians. Okay, and then my degrees will cancel. Degrees cancel, and I'm left with 57.2958, and then I would multiply that by pi, which is about 3.14, and then divide by 180. And that's an approximation here. So that's approximately 0.9994. 0.9949 radians. Okay, so that's an approximation. Often we're going to be able to get exact conversions. So let me just do another one here. Let's say that we wanted to convert, how about 135 degrees, and I want to convert that to radians. Okay, so I want my degrees to cancel. That's the same thing as pi radians. My degrees cancel. And so then I'm going to have 135 times pi over 180, and those are radians. Now 135 and 180, those are both divisible by 5, and so 135 divided by 5 is 27. 180 divided by 5 is 36, and then you can keep simplifying. Both of those are divisible by 4 or by 9. And so then this would be, let's see, 27 divided by 9 is 3. 36 divided by 9 is 4. So that would be the same thing as 3 pi over 4 radians. And we get lazy and don't always write that word radians, because if there's no degree unit, then we can just assume it's radians. Okay, so we're often going to want to use the exact form and not simplify as an approximation. So this is an approximation. And whenever you're being asked to find the exact answer, then you're being asked to keep that pi in there and not use the 3.14 approximation. And it is good to really try and understand what all this means. So if we are talking about halfway around a full circle, one whole rotation, halfway around is pi. Well, half of that, 1/2 times pi, that would be pi over 2. Okay, so we can count by pi's over 2. There's 1 pi over 2, 2 pi over 2, which simplifies to pi. Here would be 3 pi over 2. And then counting another half a pi would get us to 4 pi over 2, which simplifies down to 2 pi. Okay, what would that be in terms of degrees? Well, we already know some of these. Halfway around is 180 degrees. One full rotation is 360 degrees. Half of pi, well, we know that that's 90, right? But pi is 180. Half of 180 is 90 degrees. Okay, so if every time you see a pi over 2, it's worth 90, this would be 3 times pi over 2, which is equal to 3 times 90, which is 270 degrees. Okay, so we can count by half pi's. Let's see what happened when we count by thirds of pi's. Okay, so halfway around the full circle is pi. And then we can count by pi over 3. There's another third. We've got 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. That would simplify down to 2 pi. And 3 pi over 3, that's just the same thing as pi. Okay, now, what is 1/3 of a pi? Well, remember that pi is worth 180. So 1/3 of 180 is 60 degrees. So there's my 60. Okay, if I take 2 of those, each pi over 3 is worth 60. So 2 times 60 is 120. 3 times 60 is 180, and that makes sense because halfway around is 180 in degrees. 4 times 60, that's 240 degrees. 5 times 60 is 300 degrees. And 6 times 60 is 360. All right, so counting by fourths, we already have some of these done. This is pi over 2. Okay, but half of a pi over 2, half of a half is a fourth. So there's pi over 4. We know this is 90. Half of 90 is 45 degrees. Okay, we're going to do another. So here was pi over 4. Here was 2 pi over 4, which simplified down to pi over 2. This is 3 pi over 4, 4 pi over 4. Okay, this one we already know is 180. We're just adding, every time we're just adding another 45 degrees. So 90 plus 45, that's 135. Okay, adding another pi over 4 would be 5 pi over 4. 6 pi over 4. That one simplifies down to 3 pi over 2, which we already figured out is 270 degrees. This is 2 pi, which is 360. We're really close, so we just need this one. This one was 6, so now we're going 7 pi over 4. Okay, and then you can always just keep adding 45. 180 plus 45, that's 225. 270 plus 45, that is 315 degrees. All right, we just have one more. And that's counting by, these were fourths, these were half pies, third pies. Okay, so now we just need to do sixths of pies, or pies over 6. Okay, we've done a lot of them. We've done our thirds, our halves. Okay, pies over 6, if this is pi over 3, half of that is pi over 6. This one we already did was pi over 2. This was 2 pi over 3. But we can also think of this in terms of 6. There's 1/6, 2/6, 3/6, 4/6. This would be 5/6. I kind of like to think of that like it's a little tiny piece, one little sixth away from a full rotation. This is 6/6, which is the same thing as pi. Okay, and now here I need to add an additional 1 to 6 pi. Okay, so 6 pi plus another 6 pi over 6 plus another pi over 6 would be 7 pi over 6. Okay, all the way around here, this would be 2 pi in terms of sixths. That would be 12 pi over 6. So if I'm just a little tiny pi over 6 away, I'm really close, but I haven't quite gotten there yet. I'm at 11 pi over 6. Okay, and then all the rest of these we already did. This was 3 pi over 2. This one we had done from right here. 4 pi over 3. This one was 5 pi over 3. Okay, and we have all of these degrees already done. Most of them are already done from our pi's over 3. We just had a couple more to do. So these are all done. We just need to do pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so let's look at what this is worth. Pi is worth 180. So 1/6 times 180, that would be 180 divided by 6, which is 30 degrees. So that's 30 degrees. This is 180. I'm a little tiny piece. I'm a little 30 degrees away from 180. So that's 150. Here I'm a little 30 degrees past 180. So that's 210. Here I'm a little 30 degrees away from 360. So this one is 330. And we're done. So this is a lot. It's a lot of information. And here it really is the foundation for moving forward in this class and understanding trigonometry. So here are some really common angles in both degrees and radians. And I do recommend having this printed out and so that you have easy access to it. This will come in handy. All right, so let's look at supplementary and complementary angles. I'm going to change this a little bit. We're going to do 2 pi over 7. All right, so complementary angles, those are the ones that add up to 90 degrees. Supplementary, those are the ones that add up to 180. So just a little quick review from geometry. The complementary angles, I'll do that over here. Those are the ones that add up to 90. So if I have something that is 52 degrees, and I wanted to know my complementary angle, let's call that angle A. Well, angle A and the 52 degrees, those add up to 90. That's a right triangle. Complements are right, you're right. It's right to give a complement. Okay, so then angle A would just be 90 minus 52 degrees, which is 38 degrees. Okay, so then supplements, those add up to 180. So if I had my same little 52-degree angle, oops, that's not quite drawn to scale, but that's okay, 52 degrees. Okay, and then I wanted to know, well, what is the complement or the supplement here? The angle, both those angles need to add up to 180. Okay, so then my supplement would be 180 minus 52, and that is 128 degrees. Okay, so that's a little review from geometry, but let's look at what how we would do this in terms of radians. Okay, so a complement, that's the complementary, those are the ones that add up to a right angle, and that is either 90 degrees, but in radians it's pi over 2. Okay, so my angle of 2 pi over 7 plus, here I'm going to kind of make this a little easier. Okay, so let's see, I have 2 pi over 7, that would be some little angle here. This is 2 pi over 7, and I want to know this complement. So my angles, whoops, add up to pi over 2. So then the complement would be pi over 2 minus my angle, which is 2 pi over 7. And now we have to get a common denominator. Let's have it be 14ths. So then I would have 7 pi over 14 minus 4 pi over 14, which would be 3 pi over 14. So that's the complementary angle. Okay, and then this would be complementary. Okay, and then the supplement, that's the angle that's going to add up to 180, which is the same thing as pi. Okay, so I have my little angle given, which was 2 pi over 7, and I want to know this supplement. So angle B plus the angle that was given, which was 2 pi over 7, that's supposed to add up to pi. Okay, so my supplement would be pi minus the angle given, so minus 2 pi over 7. And then we have to get a common denominator. It's going to be sevenths. 7 pi over 7 minus 2 pi over 7 would be 5 pi over 7. And then we can just throw a little review of algebra in there with this idea of supplementary and complementary. So you can go ahead and pause the video and see if you can figure these out. Okay, a little hint would be to set up an equation. And then you can solve for m. Okay, and same thing for this other one. 6k equals 180, so 10k equals 180. And k equals 18 degrees, and then just plug that 18 in there and solve for both your angles.